Hello, today we are going to present the evidence tree, modern physics, with my classmates Ángel Hernández, Eduardo De Bequis, and me, Adriana Aguilar. The first slide, we're going to present uh, three concepts, current, voltage, and resistance. Current is when particles move from one place to another inside a closed path. The units are amperes, and current always flows from positive to negative. Voltage is the electromotive force that is generated from the action of resistance on the current of a circuit that pushes charged electrons through a loop. The voltage is proportional to the current. Resistance of a wire is an inherent property of a conductor. Its units are ohms. Resistors is a device that resists or limits electric current.
There are two types of electricity flow, the direct current and the alternating current. The alternating current is the one that is better to transport the electricity and don't lose any volts. There are 10 devices for alternating and 10 for direct. The alternating devices are chargers, multiple connectors, televisions, hybrid and electric vehicles, lamps, kitchen devices, gives power to the houses, computers, refrigerators, and air cooler. And for the direct energy, is the energy that the power source is a power source that can be recharged, like the cell phones, laptops, toys, flashlights, calculator, remote controllers, wall clock, speakers, photos cameras, and alarm clocks.
The methodology of electricity starts with Ohm's law, which states that current flowing through a given conductor is directly proportional to the potential difference between its ends. The mathematical expression for it is V, which is the electromotive force, equals current times the resistance. Uh, Two main points to consider when studying or analyzing circuits is that in series circuits, current remains the same for all resistors. And in parallel circuits, voltage remains the same for all resistors. Next up, we have the Kirchhoff's law. The first Kirchhoff's law is the current law, and it states that the sum of the currents flowing into the node is equal to the sum of the currents flowing out of the node. And finally we have Kirchhoff's voltage law, which states that in a closed path, the sum of voltage rises, voltage that go from low to high is equal to the sum of voltage drops, voltage that goes from high to low. This basically means that the voltage leaving a node in a circuit is equal to the voltage getting into the node. Next, we have the methodology for magnetism. First, we have Ampere's law, which gives a relationship between magnetic field and electric current, and it is applied for cases of high symmetry, meaning that it is only applied when a magnetic field is not interrupting, where more than one magnetic field is not interrupting an electric current. And the mathematical expression is the integral of the uh, magnetic uh, magnet of the magnetic field magnitude times the length of the wire, uh, which will be equal to the permeability constant times the enclosed charge. This equation basically means that it is the sum of each individual piece of the wire, giving its magnetic magnitude, and it will always be constant for the permeability multiplied by the enclosed current. The next up we have the Ørsted's experiments. It was discovered that the flow of a current passing through a wire caused the deviation of a compass. He found that the electric current was the source of the magnetic field and that it produced a torque over the compass needle. Next, we have Biot-Savart experiments, which they consist of magnetic fields near to different kinds of circuits. Then it was deducted a formula that allows calculating the field B of any circuit. So the magnitude of the magnetic field will be equal to the enclosed charge divided by 4 pi times the integral of the current times the derivative of the length times the angle, which is the r with the arrow above it, or in this case that r will be a vector divided by the radius or distance at any given point from the field squared. Basically, an element of the current that represents all the wire is taken, so that the field produced by all parts of the wire can be combined to find the total field. So we design an applied circuit, and as you can see, we have resistor 1, 2, 3, 4, and 5, which they are connected in a mixed way. And an important fact to consider is that the most important use of mixed circuits nowadays is in the chip industry. Now, when we were solving the circuit, we applied Ohm's law and Kirchhoff's law. So, as you can see, we found the individual voltage, current, and resistance of each resistor.
Well, after my partner explained how the electricity works, I'm going to explain where it's produced and how. Well, principally the solar energy is come from fossil fuel, and then it's transported to places that are near to the population. After that, that alternating energy is converted into direct energy, so it can be used for the houses and those devices.
Here we're going to explain and show you some examples of applications of the quantum physics in everyday life. First, the toaster. The heating element of the toaster glows red to toast a slice of bread. The rod in the toaster gets hot, which in turn is responsible for toasting the bread, and it is a clear example for the use of quantum physics. The second example is computer, mobile phone, or any other devices. Quantum physics talks about the wave nature of electrons. This forms the structure of solid objects of semiconductors are built, and it uses quantum physics. Laser. The working of lasers involves spontaneous emission and fluorescence. Electrons will jump to a high level excited, and that will make the light come out of that object or device. Global Positioning System, or GPS. The distance and time between your current location and the destination are calculated by satellites. Each satellite relies on quantum physics. Telecommunication. Fiber optic has made possible two-way and quick communication. Fiber optic is possible by lasers, which are devices of quantum physics. In conclusion, we use the needed formulas to calculate every problem of electricity or magnetism with success and follow every step to come for to obtain the result correctly. Modern physics is really important in our daily life. Although we don't notice it, while we're walking, while we're using headphones, cell phones, computers, camera lens, satellites, GPS, we are applying modern physics and some laws and principles of scientists. Electricity has also many uses in daily life. It is important for operating all appliances, lighting, and all technology. We learn many formulas how a light circuit works and units. Magnetism is also important in every aspect of human life. Thanks to them, Thanks to them, many essential artifacts like medical equipment, refrigerators, cell phones, computer, among others, work. We think it is important to learn about this because it is everywhere we go nowadays. All this knowledge of this course will be really useful for the rest of our lives. Thank you very much.